Hello all. Good evening to everyone. My name is Harsh Manwar and I'm a senior software engineer at Oracle. And in today's webinar, we'll be discussing about the DevOps and its uh, application mostly. Now, if we move ahead and if we see the takeaways you can take from this webinar, then we'll discuss about what is DevOps. We'll understand its tools, technology, how we can implement it into our culture, all the methodologies and all those things. We'll look into the cloud native part, also see if, demo for the infrastructure as a code. So I will also show you one demo, how the actual infrastructure as a code works. We'll discuss also about little bit serverless and event-driven technology, and how also DevOps help over there to the development team, organizations, and all those things. Once that serverless and event-driven discuss, then we'll move ahead into the CI/CD side. So in CI/CD, we'll discuss about the GitOps, we'll discuss about CI and also the CD. We'll also explore the difference between continuous delivery and the difference about continuous deployment. And once that is done, we'll go the little bit on advanced level side, which is multi-cloud and the hybrid cloud. And it is little bit on advanced DevOps side, but if you just stay back, then I think it would be easy for you to understand what is happening over there and how you can, as a DevOps engineer, to implement the systems and all the tools and technologies. So we'll also talk about that. And at the end, we'll also discuss a little bit about the SRE. So it is more like the difference between DevOps and SRE, or how you can leverage or be the DevOps or SRE, anything. So we'll discuss about all these takeaways into this webinar. Now, let's first start with the discussion what is the DevOps and why it comes into the picture, or from when this evolution started. If you see the diagram over here, you can see the development processes. So previously organizations were following the process like a waterfall. So in waterfall model, what actually happens is when you're one process, or I can say suppose you are developing one application and there is the analytics or the discussion phase is going on. Once that phase is done, then you move to the next phase and you start the development of your application. Once the development phase is done, then you move ahead and give your product to the customer. So it is a time-taking procedure with a waterfall model. And with waterfall model, whatever the application architecture that comes at the end is kind of a monolithic architecture. The monolithic architecture is like you have the one single file, or I can say one single package. Inside that package, you have everything. Small files, the code files, dependencies, images, and all the files that is required for application to run. Now, issue with monolithic architecture is that when you plan to migrate this application from one server to another server, or you have any issue, then it is very hard to debug the issue. Inside this type of monolithic architecture, because the application is very big and you cannot go across the 5,000 lines, or it will be definitely more than 5,000 lines. But if it is monolithic, then it is very hard to debug, migrate, and handle the application. And as you all might be having the idea, this type of old application architecture previously used to get deployed on the physical servers. So it is into kind of rack and available into the data center. If anything goes wrong, you have to restart the server or anything, then you goes over there, you do the restart and all those things. So it is very hard to manage the application infrastructures and all this together. Once the evolution came, people started adopting the agile method. So it is also again the development process. In agile, you are more worried about how the application is being developed, or how the cycle should be there to develop or create the application code and write the code. And generally, when the agile comes into the picture, application architecture move to the N-tier architecture. Now you again might have question, what is this N-tier? So in when you create any software or application, you have the different tiers. For example, you have, it is not a kind of tier, but for your better understanding, I'm just giving you the example. Like you have the front part, which is showing to user. You have the backend, so which is only doing the job about writing the queries and data to the databases. So you can consider this as a tier, but in backend also you have the different tiers. So one tier is only handling the data part. Then you have the storage tier over there. All your files and everything is stored. If you are uploading the images and all those things. So if application is big, you might be having the N tier. So it goes with 1, 2, 3 till the end. Depends on your architecture, how you are creating the application, how many tiers you are planning. And these types of applications started being deployed on the virtual servers, or in another word, we call it virtual machines. And the use of virtual machine and virtual servers goes once the cloud comes into the picture. So if you have heard about AWS, Google services, Oracle Cloud, and all these cloud provider provide you the basic of virtual machines. So this type of application previously being deployed over there, and it is mostly on hosted. So hosted means you are using the cloud or you are using third party that provide you this type of machine, and you can directly leverage without managing and handling the much things. Now, again, evolution comes into the process and people started adopting the DevOps. Now, what is DevOps is more about deploying the application. It is also about setting up the methodology in your organization. So you are worried about how the people will do the communication. You are also worried about automating everything. So you plan the things, you do the coding, you again do the building. So DevOps is more about like creating the automations and smoothing the general process of development into your organization. So many organizations adopted this methodology. They started with the DevOps also. Some combine the methods like Agile, and with that they adopted the DevOps also. And the microservices application architecture again comes into the picture. Now, what is microservices is like just imagine you have the 5 teams and one team is only working on the account. So what is account means, if you are using the Amazon or any application right now, then you have the account that is handling the sign up, sign in process. One team is only handling the catalog application. So when all these different services and the teams merge together their code, merge together this code, the whole applications create, and that applications or whatever that architecture is there, it is known as the microservices. And these microservices mostly get deployed with containers only. So if you have heard about the Docker, then it is the #1 tool right now that every developer or DevOps engineer might would like to learn or regularly like to use that specific tool for the containers. So we'll also a little bit discuss about container. It is also currently one emerging technology. And as a DevOps engineer, you should be also knowing what is container and everything. And again, these people are started deploying these containers on Kubernetes, containers on cloud, and they started managing the containers with Kubernetes. So we'll also discuss what is Kubernetes and how you can manage the containers with Kubernetes, doing the orchestration and all those things. So that was about the evolution of computing. We discussed the application architecture, the process, like where actually DevOps came from, the current emerging container technologies and everything. If you have any question, feel free. We'll discuss at last once this webinar ends. So feel free to write into a chat box. I will answer all your questions. Now, this is actual DevOps, how it looks like if you're trying to showcase into the graph. So it is the merger of development process, quality analysis, the testing, and it is also about the operations. Now, if we see the typical software cycle, how previously it was being deployed, that you got the idea about one application, then you get the requirement, then you code it, you test it, you create the build package, and then you deploy it. Now, once your code is ready, then there might be the developer team and there might be the operation team. So operation team is more worried about deploying the code to server. So for that, what they do is they install the necessary tools on server, then they set up few firewall rules so there won't be any type of attack on your servers and all these things. So operation team is more worried about keeping the server running, while the development team is more worried about doing the coding and creating the new feature into application or the software. Now, if you see this, there is the kind of gap between dev team and the operation team. So as a DevOps, it's all about creating the continuous going thing. Suppose if developers are done with the coding, then after that they provide the build to the operation team, then they do the deployment on the server. But again, if operation team have any question or anything, then they again have to go back to developer team, and it create the issue. So as a DevOps, you set up the or choose the tool with that you can keep keep going this process without any interruption, and application can run and get deployed, and easily you can release the feature into your application. So you do the code, build, test, packages, all the things mentioned over here. So all this together with automation, it create the DevOps methodology. So it is, as a DevOps, you can just consider like you are creating the automations for each one of step. Now, as I mentioned about developer team and operation team, so it is the same thing, like developers just worried about their code and they don't have idea how to deploy the application on server. And the operation team is worried about the server. There won't be any type of attack, or if a developer have not created proper documentation how to run the application, then operation team won't be having much idea how to set up that application on server. So now you can see the difference. Both are worried about their role, but there is the gap of communication, or there is the gap which can cause the issue with your end customer. Anyhow, you have just deployed the application, but the customers are not satisfied, then it will be issue. And also they might get the release features a little bit late with the issues and all those things. So again, over here mentioned miscommunication lead to the release delay. There is no the automated process, no documentation, no checklist available. So DevOps is try to solve these challenges. Also, if you see for operation team, there is the tons of manual efforts. Suppose today the one developer is informing operation team, I need a one server to do some testing. Now operation team create one testing, execute the command manually one by one, and it gives the that server for use to one developer, for example, internally. Then suppose another day another developer come and he have also the same requirement. Then each time operation team have to create the server manually, or set up the tools, packages, and all those things manually, and running the one by one commands. And it is manual preparing the deployment environment on all this. All these efforts are so manual. They also have to take care about the user access, permissions, downloading the packages. It is very slow process. There could be the chances of error, and also there is chances of version mismatch. So if there is any version got updated and by mistake I'm running the same command and it is default taking the latest download only of package, then there could be chances of version mismatch. So there is so much of manual work in operation side. So DevOps also try to solve this issue. Also, there could be chance of knowledge sharing issue. So suppose I have created one server and run command that I forget to add into documentation, then there is the issue of knowledge sharing. So DevOps, if you implement or you are going with DevOps, then it can give you the speed, reliability, also gives the improved collaboration between the different teams, and with that you can rapidly deliver your application software. You can also scale your servers very well and quickly with the time. Also security things will be there. So once the security comes into the picture in DevOps, there is one term called as DevSecOps. So it is the whole different side now, and there is also different role now available into organization. So this specific role, DevSecOps are more worried about the security side. So that was about the DevSecOps. And again, the DevOps is only mentality, how you set up the process into your team or into your organization. Normally, we ship the small increments quickly and safely. That is what the end goal is. Now, DevOps has a separate role. When I've been talking about everything, the DevOps and this roles, so generally what happened in organization, if you are working for the small organization, then there could be chances there is fewer number of developers are there. So developer might be following the practices of DevOps, and they are also doing the same thing that operation team is doing. So the one DevOps is following the methodology of DevOps, and he's doing the both work of development and also of operations. In some of the organization, there is this dedicated team of operation team, and that is trying to implement the DevOps. And in larger organization, there is chances the specific DevOps team there. So the specific DevOps team or whoever following the DevOps, they try to set and choose the tools that they will be using. The tools can help them to easily release the software version, handle the software, and they can quickly create, build, and give the software release to end customer. That is what the end goal is as a DevOps role. As a DevOps engineer or as a role, you will be knowing this type of tools. So it is about the container, cloud, monitoring, source code, and everything. So it is, we are not going much into this deep things about the roles and tools and everything. Okay, so this is one diagram that is talk about the tools and technology of DevOps. So again, everything is mentioned. If you see for the code, you have source code repository for the Git. You can also use the tools like VS Code to do the code, and then you push it to GitHub and everything. For build, you have the options available like Maven and everything. For testing, you have the Selenium, JUnit. So these are the general software that widely used, but also it's again depends on organization or the team that what they are comfortable with. If over here some are familiar with the another CI/CD tool, then instead of Jenkins, they can choose the Circle CI or any other available tool that they are good with. Over here, a few tools for the monitoring, and here for deploy, you can run it the container, which is Docker, AWS, and all this available. For operate or operations or to deployment, you have the Kubernetes, Safe, Ansible, and this is tools and technology that generally DevOps use. And again, this is the list of tools. Again, it is not the specific tools that used, but these are the widely used tools that most of the organizations currently using into their development process. So for collaboration, you have the Slack, Jira software for the Confluence management and all those things. Okay, now let's discuss about cloud native DevOps. So what is basically cloud native mean? So the cloud native is more like using the modern tools and technology to support the application, and you can easily deploy it on the cloud. So cloud native means your application is mostly ready, or you are planning to run it on fully on cloud only. So as a cloud native, you mostly people are creating the containerized software only. So you are creating the package, and inside that package, you are running the one single services. Also, as a cloud native, your container or whatever you are creating, your application should be dynamically orchestrated. So suppose you are on running on one cloud today on AWS, and you have some requirement like Amazon increase the price. If your application is cloud native, then the considering that it will be very easy to run on the AWS cloud or across the different cloud. So that is what the idea is behind the cloud native. Also, some of people use the microservice architecture as we discussed on the evolution, like what is the microservice. And also there is another things known as serverless. We will discuss about that also. People are now moving to that side also, uh, using the serverless and leveraging the serverless technology. So it is again this cloud native is approach to building and running the application that fully take the advantage of cloud. So that is what the cloud native is. Now, what is the role as a DevOps for the cloud native is you again choose the tools, you again set the process. You create the automation, write the automation that run on your cloud and do specific operation for your application and software. So you can see the diagram over here. So cloud native is combination of DevOps. You do the CI/CD part, microservices, containerization. I will also show you one demo of CI/CD and everything. So we'll discuss all those things. Now, this is what actually mean the cloud native and DevOps. So DevOps is kind of culture that you try to implement in your team or organization. You do the continuous automation of the things. And on the native side, you are just building and leveraging the cloud tools and automation that already available, or you are creating by on your own to run it on cloud. So that is what about cloud native and DevOps. Now, these are the 5 key DevOps technology areas. So if you see, the first one is infrastructure as a code. We'll discuss and how it solves the issues. So that is also the emerging application of DevOps engineer. I have also seen there is the specific role now available. So you can be just infrastructure as a code guy if you are interested into that, and on a daily basis you write the code that create the infrastructure. So there is also a specific role is available in a few of the organizations. The next one is the CI/CD, so continuous integration delivery or continuous deployment. We'll discuss that in further. The further next is monitoring, metrics logging, and the application monitoring. This is also very critical point that you should be knowing. Then APIs and microservice management, communication and collaboration. This is what the make the DevOps process all together. Okay, now let's start with infrastructure as a code. Now, why it is required and what is infrastructure as a code? So as name suggests, you are writing the code to create the infrastructure. So as I gave you the example about one developer requesting operation team to create one server, and another one is requesting another day. So there is so much of manual job. Instead of that, what if you can run the what if you can write the code to create the server and do the automation, like once your server is ready, it do the this list of command every time and your server is ready. So you can run the code multiple times and you can create the same thing every day if it's required. So that is what the infrastructure as a code. You write the code and you create the server with that. I will also show you one demo about ISE, and you can create the different environment with the single code. So it is like you have the single code and you can create the as many servers as you want. Now, let me quickly show you one demo for ISE. Okay, so here I'm in Google Cloud and we discuss about the VM, right? So I will be creating one server with infrastructure as a code, and uh, you can see the advantage. I will also show you the code first. Okay, so my code is open over here for your reference. What we are trying to do is we are creating one compute instance, or I can say a VM server. It will be having the Debian 9 OS. And these are the few variables like the what will be the name of my server and all those things. This is the zone that is the part of cloud requirement, and this is the simple code. With this simple code, I will create one server. So the same code available over here, I have just copy pasted over here. And what now I will do, I use the tool called Terraform. That is widely used. Also, multiple tools are available currently in market. You can leverage as you like, but mostly people are using the Terraform. And once your code is ready, you can give Terraform apply. And it will apply your code and it will create the server for you. So it is now asking me like whether I should go or not. So before that, it is showing me everything, what will get created, what the command will get run. So once the server is up, it will install the Nginx and run few commands and everything. So I'm just giving the yes, and it will move ahead. And you can see the new server will be coming up over here. Yeah, so as you can notice, this is my server, which we have created with the code. And if I run this code multiple times, I can also create the multiple servers as someone requested. Instead of going manually clicking on the buttons and setting up and giving it to person running the code manually, all the code are already executed that I mentioned. For that, if you notice, where is uh, okay, so actually that shell script file is not available. Otherwise, I have added it is not part of this demo. But this is what a Terraform is a code. You can write the code to create the infrastructure. So it is not just about creating server. With this, you can create the different services of cloud that cloud provides. You can create the buckets, creating the database, manage the database, and all those things with this. And the Terraform is well-known tool I use for this one. Okay, and you can also manage the same thing if you do the Terraform destroy. And with that, you can also remove the and delete the server. So I have just gave the yes, and as you can see on my screen, this server will be deleted. So you can see the status, it is being stopped, and soon it will get removed. Now, the another benefit with infrastructure as a code is that suppose you are DevOps engineer, you know the infrastructure as code, then someone is joining my team, then they can see the code only and get the idea what is happening into the infrastructure, how the servers are being created, what is the configuration of server, and they can easily get the idea what is happening into the application instead of giving them access to these things. And they might create any trouble if they have don't much idea around the things. So that is also one of the benefit to adopting the infrastructure as a code. Someone can see the code and get the idea what is happening. I hope my screen is visible. Anyone could confirm once, please?
Yes, please. Your screen is visible. Yeah.
Thank you. Thanks, sorry. So, yeah. As we discuss about the infrastructure as code, we provision one server and we destroy it. So that was the kind of benefit that we get if we adopt for the infrastructure as code. If you are DevOps engineer, it is a necessary skill to having the idea about this technology tools and everything. Now let's move ahead and little bit discuss about the serverless. Now, as the term or name itself says, the meaning of serverless is kind of you are deploying your website without the server. So either it's your application code, website, or anything, you are trying to set it up or run it onto the cloud without having the server. So what generally happens when you create the server on your own cloud, then it start creating the billing for you. So suppose you run your server for 24 hours, you have to pay the bill for 24 hours only. So this specific things known as the pay as you go. So the amount of time you use your server, you have to pay for that specific amount only. If you run your server for 15 days, you have to pay for that 15 days. If you just run for 1 hour, it will be, or you have to pay billing for 1 hour only. The benefit with serverless that you don't have to provision any server. So you are not creating any server, but your code will be running on cloud. So it will be based on the millisecond. If your function is there that is running and handling the API request and all these things, then you will be just paying for the that compute of 4 seconds only, or the number of requests you are getting. So comparatively with server, the serverless is kind of affordable option. If you are in your starting phase, initial phase, you are planning to do the cost cutting, and the billing for you is coming a little bit higher, then it is you can adopt the serverless. Again, there is few requirement before you adopt it, but we are not going much into the depth about the serverless. But that is the thing. With serverless, you have also the great benefit of scalability. If the large amount of request is coming, then you don't have to much worried about it, because serverless is fully managed by the cloud provider only. You just have to worried about your code only, the server scaling. Whenever huge traffic is coming, then you don't have to manually create the multiple servers, and you can handle the traffic or anything. That automatically scaling will be there, that handled by cloud provider team only. You don't have to worry much with serverless. So it is the benefit of serverless. And if, for example, you have created one server and it is ideal for 30 minutes, then also you have to pay the bill for that 30 minutes, and total it is running for 1 hour. Then out of 1 hour, you have only used for 30 minutes, but another 30 minutes it was just available over there. So you have to pay for the 1 hour. But over here in serverless, you don't have to pay anything for that condition if it's idle. So that is also one advantage with serverless. And now uh, people starting and following this architecture, it is called the event driven or serverless event driven. And as a DevOps engineer, you might be architecting this stuff or creating this type of services, how the flow will go from and how the services will talk to each other internally and all these things. So as a DevOps engineer, this is also one thing. If you are into architecting side and more interested into event driven and all those things, then this is also one good application to learn. So what actually happens in event driven is that suppose any event happen, then and then there is some processing goes on. So for example, over here, if you notice, there is this one event is happening. So suppose I have one URL, or I have an endpoint or domain, for example.com, and I hit that domain, and then there is some processing will happen in my function, and that function might be having the code written into like Node.js, Python, Java, anything. And if anything need to be done, then it will call the another service, save the data into the database. Otherwise, it will just give me the response, and I have to only pay for that 1 or 2 milliseconds that need to process this function. So it is one example of event-driven thing. Whenever any event happen, then and then it will do the processing. Otherwise, it won't be handling or running straight. So that is what the idea is. That I will also show one small demo of a serverless. Now, that was about the serverless and event driven. Now let's discuss about the CI/CD, and this is major role that DevOps engineer might be doing in organization, creating the automations, integrating the CI/CD, and do the deployment of services to the servers and everything. And I will also focus one demo for the same. So stay tuned. Now first discuss about the CI. The CI means continuous integration. So over here in graph, you can notice these are the developers that are committing their code to the GitLab, GitHub, and that is the source code repository, where generally source code gets saved, and it is having the history of changes into the code, and everything will be managed over there. So as a engineer, you create or write the automation which do the continuous building, testing, and result on top of that code that is get committed into the source repository, and in return you get the result. So that is what the continuous integration is. If multiple people are or teams are running, as soon as they commit the code into the repository, it build the package, it test out the things and gives you the result. So if anything is breaking into the code, before it move ahead, you will get the result from here only, and you will get idea. This need to be done. There is also some security scanning, and all these things happen over here in CI server. So it's scan for the vulnerability, security, and all those things. So this is one diagram that you can see the same thing. A developer over here, it is committing the code, do some checks over here, runs and everything, packages, it build the packages and everything. Here a few tools, list of tools that get used into CI/CD based on the technology or code you are writing in, and it get deployed to the server. Now, if you are using the container, then this is the demo how it goes for the CI with containers. So you have the developer, you are creating the containers, and then you have the repository, artifact repository, where you push the container image. So I will show the same demo for this one, and then it get deployed to the server. So that was about the CI part. Now, what is CD? So the CD is more about deploying whatever you have created in CI. So once your package is ready to deploy on server, your application is ready, then you deploy those artifacts or that application to the server. And in server also, you might be having the different type of things. You might have kept one for the testing, one for the staging, which is similar to production, and the production one where the actual users and traffic are coming, while the testing and others might be used by the internal team, testers and everything. So from here, if you see the scenario, you developers commit the code, it gets scanned, security checks and everything automatically over here in CI server. Then the builds happen, do whatever testing need to be done. You are checking whether you are getting the proper response, pages, everything. You get the result, and that result seen, then it get deployed to the different servers. So from here, it get deployed to test, staging, and production. Now the one difference you notice over here is it is auto deploy. So as soon as someone have committed the code over here, all the process will be automatically till here, and changes will be directly used by the users without any interruption or required. So everything over here, code will get deployed to production automatically. So that is the continuous deployment. This is again the same thing. You run the test cases, build the packages, create the container, test it, push it to artifact, and from artifact it get deployed to the server. Here also, as a part of CI/CD, you might want some extra things like whenever your build is ready or it is being deployed to server, you might want email that my server is deploying new version to, my CI/CD is deploying new version to server, then I should be getting notified on email. So I will be aware and I can check what is happening, or I can keep the monitoring if required. If you have some videos and images, so you might want the CDN to show those things very well to your audience quickly. So you might want to sync those things and everything. So all these steps will be the part of CI/CD. You get the notification. Also, what happens if something failed in between? This is all automated process. If something got break over here, then what should happen? So you should have all the planning steps and everything. Now, there is also some terms known as continuous delivery. So, here is the difference between when you say the CI/CD, then it could be anything. The CI always means the continuous integration, while the on CD side, it could be continuous delivery or continuous deployment. So as we see till over here, it is same only. The only difference between the delivery and the deployment is that in deployment case, the things get deployed to production automatically without any interaction or interrupt required from the DevOps engineer, or you might want some permission from your manager or anything. In delivery, you have to give the manual permission, and once you go ahead, then and then that specific version or release will deploy to production, and user will be start using that specific release. So that is the difference between the delivery and the deployment. Now, let me again also quickly show you one demo for the same. Then we'll see the GitOps. Okay, so here I have one GitHub project that is having some code regarding the Node.js and everything. So what am I doing over here? I have mentioned my CI/CD configuration over here in YAML file. So it is building the few things. It is pushing to repository, then it is running the things. Now this is my Google Cloud Run service. As you can see over here, there is no server or nothing is running. Okay, and now what I will just generally do is I will go to the README and do some minor changes. Suppose like I have added a new line over here and I'm just committing the code to the main branch, and I have set the CI/CD setup over here, and the new build will be automatically coming. If you see the history, the new build is visible, I think. And you can see it is running and doing all the steps that we have mentioned. It will build, push, and run our code. And then we will be able to access our application, that whatever code we have written. So let's just quickly wait for a minute and it will do its stuff and it will be ready. So this is the example of CI/CD, how it's work. Also, it is just a normal general case. In larger CI/CD, you might have the tons of different steps doing the all different work kind of scanning, do the checks, test cases and everything. Over here, I'm not checking any test or those things. Now, if we refresh this page, then okay, still it is not reached at that stage. Okay, logs are visible. We can see the logs. Okay, so now it will be creating one of our service. As you can see, I have created one service named Hello Rajkot. The status is kind of ready and running. Green state in security, I'm allowing everyone to access it. And now if I just access this URL that it give me and opening into the incognito mode, and you can see our application is ready. It is hello world. The version is 1.1. The host name is localhost. The again same thing happen if I change this version from my code, and if it will be new version, then it will show me the new version. You can get the monitoring and all those metrics. Everything is available over here. Whatever you need as your role requirement for the security and everything. So this is the quick small demo about the CI/CD, how the automation goes and all those things. Now let's discuss about the GitOps. So in GitOps also the same thing. Code will be mostly available into the GitLab, but you will be running one operator over here inside. For example, this is Kubernetes. So one operator will be running over here. It could be the Argo, Flux, or anything, and it will fetch the details from the GitHub and it will do the apply over here. So that is what the thing. Instead of building on CI/CD, this will use this GitLab or GitHub, whatever the source code you are managing, and this is called the single source of truth. So all your configuration and everything will be stored into the GitHub repository or GitLab repository, and it will work as a single source of truth, and the same application or config will get deployed on the Kubernetes side, or you are managing the infrastructure or anything. This operator will do the syncs and everything. So that is what known as the GitOps. So this operator do the operations for you. As soon as you do the commit over here, this fetch the things and do the syncs. That is what the idea behind GitHub is in a normal ways. Okay, so this was about the CI/CD and GitOps. Now let's little bit discuss about multi-cloud and hybrid cloud, and what is the role of DevOps in that. Now, this is little advanced topic, and as a we are just jumping into it. So what first multi-cloud and hybrid cloud term means, when I say the multi-cloud, that it mean you are using the multiple cloud. So you can see this diagram, you have the multiple cloud over here, public cloud, and all are public cloud. So it might could happen that your HTML file or front end is hosted on GCP cloud, but your database is on AWS. And you are using this both cloud together, public cloud, and your application running over here, and it is getting few things from here, and then your client or user is accessing. So this is one example of multi-cloud. You are using the multiple public cloud over here. But in hybrid cloud, you might have one private cloud. So you have one public cloud, and what private cloud means, you have your own or on-premise data center. So you have server running into your office, into your home. You have created the cloud at your home, and your application is accessing the data or few things from that specific private cloud or private server, and few things available on public cloud. And together it is creating, you are creating the architecture, and then it used by the client or user. Again, these models are not mutually exclusive, and also not by the definition. As mentioned, multi-cloud could be the hybrid and vice versa. It goes that way. So this was about just a definition. As a DevOps engineer, if you are trying to implement the multi-cloud and hybrid cloud, then there is so many things you might have to take care about the data transition, how the request will flow, how the data will flow, and all those things, how the deployment works and everything. Let's a little bit see. We are not going much into the depth, but this is how it looks like. If you are planning to do it, then you might have to plan some strategy how the things will get deployed. So over here you are doing some arbitrary, few code goes over here randomly, it will get deployed over here. You have segmented choice, Then you have choice parallel deployment, portable deployment. If any cloud is increasing the price and it is not affordable for you, then you can just uh, port everything to second cloud, which is affordable for you. So it would be also one scenario that your company cannot afford one higher price service, then you might want to port it to another one. So as a role, you have to plan all this architecture and everything, how the data flows, requests, their code get deployed, CI/CD planning for the multiple cloud instead of the one cloud. The demo I show was using the only one cloud. You might have multiple cloud. Then you have to take care about the security, access, permissions, and everything. So now, this is also one thing now. Organizations started adopting the multi-cloud, hybrid cloud, and everything. So this is one also emerging side of DevOps that people are going into, more interested into this side. And this is how the typical normal diagram looks like. If you are using the Google, you have the on-premise data center, you have server running in your company on your data center, and how it connect to Google things, and things get used by the users and developers. This is the diagram for config management. Suppose you are running the 5-6 different servers, few are on Amazon, few are on GCP, then you might want to manage everything from the single place. So as I showed you, you can keep one Git repository. Inside that you keep the configuration policies and everything. This is one the service of Anthos that is from the Google. You might would like to leverage that for the applying the configurations, policies, and everything across the uh, uh, different resources or servers that you are running. Whether it's on Amazon or it's on GCP, you can manage everything from this single Git repository. So developers do the commit over here, then the Anthos take care about that, and the things get applied and deployed to this different servers or resources on both cloud. So this was the one diagram that I wanted to show. And last, this is the DevOps versus SRE, but mostly both are kind of friend only. So it is not a fully different role, but it is more depends on organization, what they have requirement. But DevOps is more focused on the development side and delivering the things, whatever the automation that I showed you, you are deploying the application, writing the CI/CD automations and everything. So that is what the job of DevOps is. On the SRE side, you are mostly focused on enhancing your system availability and everything. You are more worried about your SLI, SLOs, SLS, and everything. So which is you are telling your customer that our server and our application will be available for 99.999. So that is what you are giving the confidence to your customer, and you are telling them our application will be there. So that things will be managed by the SRE. They take care about the release, how it will get deployed to production. If anything goes, then they handle the support, do the escalation requirement, everything. On the DevOps side, you set up the tools, you plan out the process, and it's more about making it more quicker and deliver the feature as soon as possible. So that is what the difference between DevOps and SRE. But I have seen DevOps working as SRE and SRE working as DevOps. So both are, I think, kind of friends only.